So what are we doing?
We are plumbing the depths of the astronomy lore and discovering what lies beneath. From the most widely known and celebrated accomplishments in all of space science, ranging to the obscure that few have encountered. So join us as we explore the Astronomy Iceberg.
Wait a second. We should have done 9 layers. Then it could be also Dante's Inferno.
And like a 9-layer cheese and bean dip.
We didn't think this through. Cut, we're recording another day.
Now, if you've never seen one of these kinds of videos before, we're basically going to be looking at a whole range of astronomy topics, ranging from the surface level that almost everyone knows about, to really niche things that only people in the field have ever heard of, and hopefully having some fun along the way. So join us as we talk about the Astronomy Iceberg.
I guess, Ansh, we're starting with you.
Let's start on the surface level. So my first topic is the Hubble Space Telescope, which is probably one of the most famous things in all of astronomy. It's a space-based telescope, and it was pretty revolutionary for the time because there weren't a ton of actually really great space-based telescopes before it. So Hubble was originally supposed to launch somewhere around 1983, and it didn't end up actually launching until 1990 or so. So with all the news and kind of the buzz around the Artemis program and how it's gotten delayed, lots of criticism for budget and cost overruns, and some of which are rightfully so. It's important to note that all these delays in the beginning don't necessarily mean that the program is doomed to fail.
The same thing was said about JWST.
Exactly.
With
True.
how long it took to get done.
Exactly,
So-
and it turned out amazingly.
If you want it done right, take as long as you absolutely need to do it.
Yeah,
If only Hollywood could learn this.
you're making some dangerous enemies.
Only
Ron.
multiple things could.
But its really monumental achievement was just the kind of science it did. I mean, this telescope was really, truly groundbreaking. It sees in the ultraviolet, the visible, and the infrared, so it's got a good range on it. And that makes it one of the most versatile telescopes that have ever been launched. It's determined things like finding supermassive black holes, determining the age of the universe, and finding the expansion rate of the universe, and it's just really had some amazing science. And not to mention the absolutely amazing and incredible pictures we've gotten from it throughout the years. If you've ever seen a famous picture in astronomy, it's probably from Hubble. And one of the cool things I learned while researching more about Hubble is that technically anyone can submit a proposal to observe using it. So even just random people in the public can
Get on it.
It's your time to shine, Active Galactic viewers. With the launch of the James Webb, obviously there's a ton of excitement, and rightfully so, but Hubble is still around and it's going to be doing some great science.
My surface level topic is kind of similar, the sort of thing that everybody knows about. The Apollo missions, specifically human spaceflight, some of the landmark achievements that have happened over the course of the history of spaceflight. It doesn't get more iconic than seeing a Mercury capsule or to hear the one small step soundbite from those missions.
It's one small step for man, one giant leap for mankind.
Just about everybody on the planet has heard it at some point or seen the imagery. That is why it fits so well into this first slot, and it's something that we are continuing today with Artemis, taking our next steps into the vast, open void that is above us, that is both incredibly hostile but also welcoming to us going and poking things.
And liftoff of Artemis 1. We rise together, back to the moon and beyond.
I think I've read something like 500 million people watched the first Apollo moon landing live, which is just crazy. It's like one of the most, at the time, it was like one of the most watched events in history, and it still is.
Imagine what it'll be like for Artemis.
Especially the crewed one,
Yeah.
that's coming up too.
Yeah.
I mean, more access, but also more things vying for attention.
Yeah.
Do you think we'll beat 500 million?
It's also, it's not a first anymore.
It's
Been there, done that.
But
it's
it's
a more
been 50
recent,
years.
though. Yeah, exactly.
It's not a first, but now we get to see it. in
All right,
HD.
let's go on record. AGV viewers, bet. I'm betting less than 500 million.
Less
Whoa.
than
Live.
500 million?
How much money are you going to put on it?
Live.
500 million?
I'm gonna put 2 pennies.
All right,
Oh, me too.
I'll put 500 million on more than 500 million.
Whoa.
Whoa. For the record, watching live.
Watching live.
We'll be counting.
Oh,
Okay.
I'm so gonna get that $500 million.
I guess I better have the botnet up and running.
Yep, right.
Wait, what?
My surface level was Galileo, aka that guy who was in a Queen song that one time.
Galileo
Galileo, pretty avid telescope user, found 4 moons of Jupiter. He found the phases of Venus with the telescope. The church was not a big fan. Kind of a common theme throughout history with most of astronomy people, but one thing I think we can talk about is some people think he's the father of observation, some people think he's the father of astronomy, some people think he's the father of modern science. Thoughts? Debates?
You know, I don't know about science, but what I will say about Galileo is past astronomy, a lot of his, discoveries and the way he, conducted his experiments were pretty revolutionary. As far as I know, people in the actual, philosophy of science wouldn't consider him, the father. But, the way he did his experiments on, mechanics and, that famous experiment with the dropping the feather and the cannonball off the Leaning Tower of Pisa, which apparently is apocryphal, by the way. I think he never actually did that.
Well, in my left hand, I have a feather. In my right hand, a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago. How about that?
But either way, his experiments, carefully and systematically showing that things in free fall all move at this, or accelerated at the same rate. The way he systematically did that was really revolutionary for the time, because up until then, people just kind of took the ancient Greeks' word for it. They did a lot of thought experiments and logic, but him actually doing the experiments and showing that, our intuition doesn't really work was pretty revolutionary.
I mean, he was a provocateur, if nothing else.
Yeah, exactly.
I don't know if we can say he exemplifies the best characteristics of scientists. I mean,
Look at that beard.
so
Right?
unseemly.
There's a reason why we named a planetary probe after the guy.
Yeah.
Makes me also kind of wish I remembered clearly whether or not what the timeline is between Galileo and William of Ockham, because I'm pretty sure Ockham's work was beginning to circulate around the time of Galileo. Occam's razor probably played some part in it. I don't know for sure how much of a part it played, because I'm not sure we have all of Galileo's writings everywhere. I think the church might have gone to town on them at some point.
Did.
Casual little burnings.
It was casual burnings.
I'm not overly fond of the notion of father of modern day something. We all work together. It's a collaborative effort, especially science. You can't have Galileo without Occam, without Copernicus, without any of these people. The Greeks, it builds. Why do we need to have one?
And inevitably, the people before the Greeks who had the ideas that the Greeks then said, you know what, I'm actually going to write this down.
Yeah.
Yeah.
Oh, no, definitely.
The person that's considered the smartest person or the most influential scientist, Isaac Newton, was the one who said, if I see far, it's by standing on the shoulders of giants.
But we have a tendency to hypothesize these figures. And not just with science, history too. Founding of Rome, you always look at Romulus and I don't like it.
Yeah, those Remus twins, they were, this might be controversial, but I just
They
don't-
weren't the coolest people.
But going back to Galileo naming things, I actually didn't know there's actually an exoplanet named after Galileo. 55 Cancri B. You might have heard of 55 Cancri E. Galileo's got wide ranges of things. Even when, he looked at moons. Didn't even know exoplanets were going to be a thing.
Wait, how's it named after him?
I think it's more of just a nickname sort of thing. So it's 55 Cancri B
I see.
/ Galileo in parentheses Galileo, something like that.
I was gonna say, something about 55 Cancri B doesn't exactly ring Galileo
it
to my
really
ears.
doesn't.
Ramy, what did you bring to the party? To the iceberg, as we sink,
The ice.
as we sink with the
Well,
ship.
I brought things to look at the iceberg from a safe distance. So,
I see.
if we want to be on the Titanic, just go. We didn't make it a Titanic joke. Oh my god. I chose different kinds of telescopes. Because, I don't know, I was thinking when I took my first astronomy course in high school, that was one of the first topics of surface level. You got your refractor, reflective, and then later on you get your radio, your CCD, stuff like that. The first one was the refractor, started in the 1600s. Reflective, also known as the Newtonian.
There's another configuration.
Yeah, there's
somewhere.
there's a couple different
There's the one
configurations.
with the D. Yeah.
Cassegrain, there's also
there's one
Newtonian
full
Cassegrain,
foldable.
and there's another one.
There's at least
Hi, Vicky and
We'll
Post.
put it all up there.
there's at least others.
We can make our own telescope configuration.
Yes, the AGV configuration. find one though. I feel like they've all kind of
We'll
been
come up
made.
with something.
Radio, of course, started in 1905. So different kinds of telescopes. They're good at different things. But yeah, I mean, it's the fundamentals. You kind of need a telescope in order to get actual data to work with science.
Telescopes are getting pretty huge nowadays.
We're literally a block away from just a giant building where they make mirrors.
Yeah, exactly. If you do come under our football stadium, though, it is where we make mirrors. So check out a game.
I swear, it's
Check
not
out
like a
the
casket of
mirrors.
Amontillado. Spaceman's completely different.
Yeah, come see my collection of finely polished mirrors. We've only been making them for half a year. Alrighty, so moving on to level 2, I'm going to be talking about quasars and blazars. Quasars are basically supermassive black holes at the center of active galaxies, which is pretty cool because our channel is Active Galactic videos. So it's thought that pretty much every single galaxy has a supermassive black hole in the center that's got anywhere in the range of millions to billions of times the mass of our sun. So these things are just absolute monsters. And sometimes, if some matter starts swirling around this black hole, which we call an accretion disk, it can start to get super hot and glow like insanely bright. Like some of these quasars outshine their entire host galaxy. So we've been seeing these things for years, and now we've discovered like tons of them. A lot of them also have these really crazy jets that shoot out the top and bottom that can be literal light years long, which is terrifying to think about. And if one of those jets is pointed towards us, we call it a blazar, because it's not scary enough on its own. We don't technically actually know what quasars are. That the supermassive black hole model is really the only viable candidate that we know of, but we've never seen one directly because they're, too far away and too small to directly see. So could be aliens. Could be anything.
No way.
My topic this time, however, for the second layer of our iceberg is planetary probes. This is a wide variety of missions that NASA, the ESA, and various other space agencies around the world have done, but they're not as well known, except for the rovers that NASA has put on Mars. Pretty much everyone has heard of Spirit, Opportunity, Curiosity, and Perseverance. They're rovers, they're kind of personable, they look kind of cute if you
They
animate
sing
them.
happy birthday.
They also give you real tearjerkers when they send you a message saying, "Goodbye, world. Hope to see you after this dust storm," or something like that. But the ones we don't really hear about are, for example, Pioneer missions, which went all over the place. The Surveyor missions were the missions that led up to us putting people on the moon. Because at one point, we didn't even know if you could land on the moon, or whether or not something landing on the moon would just sink through it. We literally didn't know this. They teach us something about the object that they observe that we wouldn't otherwise be able to find out. We wouldn't know a lot of what we know about Saturn, Jupiter, Uranus, Neptune. We wouldn't even have a decent picture of Pluto if it hadn't been for various probes that had gone out into the solar
Not a real
system.
planet anyway.
Hey.
We don't need that.
No.
Pluto will always have a special
Pluto's
place
always
in
a
our hearts.
planet.
The debate is still alive. Anyway, these probes have a function, and we don't really get to hear nearly enough about them. A lot of the reason for that is because it takes a lot of them a very long time to get wherever they're going.
Yeah, some of the engineering behind some probes is crazy to me. Like the Parker Solar Probe, which was really recent. The engineering behind that is just crazy. Like it's so close to the sun, it would literally like melt like anything you tried to make it out of. I mean, I don't even know how. And like the Rosetta Probe, they landed on a freaking comet. Like
A lot of these probes also have a lot of fun technologies that we don't really think about. Like we literally have the technology for ion thrusters from, say, Star Trek, Star Wars. A lot of our probes have a version of that because it's just too heavy and expensive to send actual solid or liquid fuel up there.
As far as I know, the Pioneers 10 and 11 are still going, and so are the Voyagers. So,
Someone somewhere is eventually going to come across and say, "What on insert planet name here
Yeah.
is this?"
Voyager 6.
There are markings. I obviously know what these mean.
That
Yeah,
was the
that-
whole point of
It is a
Golden
deck-
Record.
I mean, that's some kind of monkey, clearly.
It is a
Oh,
declaration of war. We must send
I
our
think-
fleet.
All right, so my second topic is the astronomy you can do with non-visible light. We were talking a little bit about radio, infrared, UV. There's a couple of those, X-rays, gamma rays, microwaves even, which is pretty crazy.
Crispy.
Yeah. A couple of those that are pretty cool. Well, microwaves, of course, we have the cosmic microwave background. The evidence that we have for the Big Bang, the oldest light we can see, is now in microwaves. Infrared UV, obviously great for telescopes. We talked about Hubble. JWST too. A couple of those cameras were built right here in Arizona.
Bear down.
Bear down, baby. X-rays, of course. Lots of things give off X-rays, and then gamma rays. Super,
Like myself.
super energetic. Oh yeah, you give off X-rays?
Yeah, you
Nice.
you all have severe
fire.
DNA mutations now. Sorry.
So, of course, there's a lot we can do besides visible light in astronomy, and lots of things emit lots of things that aren't visible, so, you know, all the invisible stuff.
Like Ansh.
Very cool. Yeah, like Ansh.
Yeah,
exactly.
I'm like a beacon right now.
Yeah.
A lot of those non-visual forms of light are just wonderful. Being able to see things that you wouldn't otherwise see. I mean, that's the whole thing that makes JWST images so much fun, because all of a sudden this nebula, which is beautiful by itself in the false color rendering that Hubble has given us, all of a sudden you can see right through it and see just how much detail there is in such an object.
They're also incredibly powerful techniques. That's how we got the image of the black hole.
Yeah.
M87 and Sagittarius A. What I did for my second layer is space food, because Grant is smart and he mentioned he had a theme and I was going to steal it, but I didn't. So, space food. The food they eat at the ISS are very space missions. It's what you imagine. It's mostly dehydrated food, a lot of preservatives, but they do get a lot of fresh fruit, a lot of fresh vegetables to help raise morale. Every 2 months, actually, as a team building exercise, they go ahead and they select food from each other's countries and have their teammate try it out. It's a great group building exercise.
That is really cool.
That's really fun.
Yeah, I had no clue. I thought I was just going to talk about shrimp cocktails that are dehydrated, but nope, there were other things.
If you've got an international space station, why not embrace the international nature of it?
I know!
Exactly.
Like, science is awesome, but so is other things. Like, getting to share that culture.
You think the Canadian astronauts are tired of getting asked to make poutine?
There's so
we
much
trusted
more
you for the
Canadian
maple
food than
syrup.
PT. I know that they have like their little water like pouches. Kind of looks like a Capri Sun with a little straw out of it, but you squeeze it and it's a water bubble.
But imagine
Little
maple
water bubbles.
syrup. And
Maple
then, like, you try to,
syrup
like,
bubble?
smash your pancakes against.
Yeah, you're like, go.
They play tennis with them.
There's only been one astronaut ever that's drank alcohol in space.
Only
Only one.
Wait.
I want you all to guess who it is.
Oh my gosh. I have to think of like who would do this.
It's Buzz Aldrin! It's Buzz
Oh, of
Aldrin. Of
course,
course it's
of
Buzz
course.
Aldrin.
What?
The one
He's got Buzz in his name.
I know!
Alrighty, so moving on to the third level, I thought I'd start off with an interesting one, which is the Harvard computers. So at first you might think this is one of those really old machines, one of those giant hulking room-sized computers with, tapes of magnetic film and whatnot, but this is actually a group of people, because before, computers were machines,
Cyborgs?
they were... Cyborgs would be cool, but these people actually might be even cooler than cyborgs. So, before computers were machines, they described people who did a ton of like manual calculations or kind of some of the more tedious work of astronomy, because back in the day, a lot of it was done by hand. So the Harvard computers were a group of exclusively women astronomers and physicists at Harvard who did a lot of like cataloging and looking at plates and basically a bunch of astronomy work from the late 1800s to the early 1900s. And they did some really, really amazing work, and they helped kind of revolutionize astronomy, moving into the big data age. Because we were starting to get into the point where observatories couldn't even process the amount of data they were getting, which is a common occurrence now, but back then that was a little unheard of. So, you had astronomers like Annie Jump Cannon, Henrietta Leavitt, and Antonia Maury, people who kind of established some of the hallmarks of modern astronomy. They made the basis for the stellar classification scheme, the OBA, FG, KM. They did a lot of important work on like white dwarfs and galaxies. So they were really impressive astronomers, and it's really sad to hear about, what kind of treatment they had to go through, which is just, it was super common and pervasive throughout astronomy and physics, having to fight for basic positions despite the fact that they're clearly capable, the low pay and just the workplace environment, which is a big reason why we really need diversity in astronomy now, because different perspectives bring so much to the table, and astronomers of color and, astronomers who are women and all these marginalized groups who astronomy's severely lacking in are some of the people who made some of the biggest advancements in the field. So,
But they're never the ones who take credit for it.
yeah.
Wasn't there recently a movie, not necessarily about the Harvard computers, but
Hidden Figures.
Hidden Figures, computers
I
for
watched
NASA.
that for
Great
my
movie.
birthday.
Yeah,
Such a good movie.
that's another depiction of it that I think everyone should watch at some point.
Watch right after this video. Actually, wait like a day so you don't compare the two because it's so good.
This is definitely from the time period where slide rulers were a necessity.
Oh yeah.
I can't even think of other tools that were very useful
So
for
much
that.
chalk.
So much paper, so much chalk.
Yeah.
I get tired if I take like an entire page for a physics equation. Like, I'm done. This is not worth it. Can't imagine what that would have been like.
Yeah. And I think I saw a crazy estimate that it was like if the computers took like a minute or two more per calculation than they did, it would have extended some of those projects by like multiple years, which just goes to show you how efficient they were and like how important the work that they were doing was.
If only they had math books.
Yeah.
Yeah, they would have gone sicko mode.
If it would have been them and
Absolutely
technology, crazy.
My topic is going a little bit deeper into the realities of human spaceflight. And also starting to get a little dark here, which is great. Because as always, as you go deeper into an iceberg, it gets darker. The challenges involved in human spaceflight. And this is just kind of the surface level, you know, what's involved with, say, getting someone into a spaceship like the Apollo craft or Artemis or the ISS. You don't think about the fact that there are a lot of things here that we take for granted. We have air to breathe. The planet keeps us within a livable temperature scale.
But not in Tucson.
It's worse out in space, I can promise you that.
Bring your
But
jacket.
we also have generally ready access to food. We have ready access to medicine, usually, depending on where you live. There are a lot of things that we take for granted on the ground that you don't get in space. So, you know, if you send someone into space, you have to take into account the fact that you need to bring your atmosphere with you. You need to find a way to keep half of the spacecraft cold and the other half warm, because in space, the part that's facing the sun is blazing hot, the part that's not is really cold. And then you also have to plan to bring your food with you, as Ramy was, you know, trying to steal from me earlier. But, you know, these are all things you have to take into account. And that's not even touching on the fact that physically, human beings are not meant to operate in zero gravity. You lose muscle mass. You lose bone mass. You have all sorts of problems, including swelling of the eyes, all sorts of other sensory issues. The thing is, astronauts do recover. It takes them time sometimes, depending on how long they've been in space. They have the ability to exercise in space, but you have to bring all of that with you, and you have to go up there knowing that these are things that your body's not built for, and you will be punished to a certain extent by your body for the fact that you are putting it through something it does not want to do necessarily.
With that all being said, I think it is very interesting how there are lots of different forms of life on Earth that all do, for the most part, pretty fine in space. Everything from fruit flies to onion plants to humans.
Spiders become terrifying in space. They learn to become not ambush predators, they will leap at their prey.
Oh my
Whoa,
gosh.
wait.
So anyone with arachnophobia, sorry.
Better stay away
Space
from the
isn't the
video.
place for you.
You're never safe.
Okay, so my third level is Sagittarius A star, which, despite it having star in the name, is actually the black hole at the center of our galaxy, which is pretty cool. If you've seen the image, that was, I believe, earlier this year, like April 2022 was when that image was released. That's actually the second picture of a black hole. So, you know, the fuzzy donut. It's in the constellation Sagittarius, which is why that has its name. If you look to Sagittarius, you kind of see it looks like a teapot. Kind of look where the steam is rising, that's the Milky Way, and so the sign of the Milky Way. Also, it was the 2020 Nobel Prize. Andrea Ghez and others proved the existence of that black hole using like stellar motions around it, which was pretty crazy. The black hole is actually like 4.1 to 4.2 million solar masses, which pretty big.
It's so cool to me that we got a picture of it, but what's kind of weird is like we saw it indirectly before we found it directly.
Yeah, exactly.
Just seeing these stars like whipping around seemingly an empty patch in space. We're like, okay, clearly there's something there, we can't see it. It's like so backwards to how our intuition would tell us. Like first you like discover something, then you see its effects, but we kind of did it backwards, which is pretty interesting.
And weren't so the U of A physicists responsible for that?
Yeah, so the
Believe
actually both of them. So both the black hole pictures are like the EHT collaboration, Event Horizon Telescope collaboration, which has a lot of ties here to U of A.
So again, because I'm a thief, I stole Ansh's idea for women in science, and I did Emmy Noether, right? Ansh just taught me how to say it. Most well known for her first and second theorem, which are really big landmarks in conservation and symmetry laws, really important to modern physics and astronomy, but not very well known. First off, she was a mathematician, not even a physicist, and she came up with these laws, but got none of the credit. I believe all of it went to her boss, actually, from Princeton. And again, if you're a woman in science, especially in that time, you don't get a lot of recognition, even though she is the backbone of a lot of modern science. You can't have quantum field theory, you can't have your string theory, you can't have supergravity, none of that without her.
She's literally, in my opinion, and I think in the opinion of many philosophers and historians of science, one of the most brilliant people who ever worked in mathematics and physics and astronomy.
She wasn't even a physicist, her background's in math.
Yeah. I mean, that just goes to show you like how connected physics and math are anyway. Like the amount of math classes I've had to take for physics, insane.
I don't like thinking about it.
She had to really fight for a position. She wasn't even allowed to teach at first. But there were some people who really stuck up for her and said, you know, no, there's no reason just because she's a woman. Obviously, she's like one of the most brilliant people. She has so much to say, and she would be an amazing teacher. Like, let her be a professor and do research. You know, people that actually stuck up for her. This just goes to show that there have always been people who have been trying to, you know, do the right thing. And I think that it's really, it at least gives you some hope.
That's actually a really good point on. Yeah, there is always hope. But her Wikipedia page is still sparse, so work on that, people.
Looks like they forgot to record an outro for this one. Don't worry, guys. I'll handle it. That's the end of Astronomy Iceberg Part 1, but we have 3 more layers coming at you in Part 2, and trust me, you are not going to want to miss it. Stuff like nuclear pasta, the Boltzmann brain, Brian May. So, hit that subscribe button and ring the bell so you get notified when that goes live. Also, in the meantime, if you want to watch our past Sofa Science video, you can check it out right here. And if you want to check this video out, it's something that YouTube thinks you'll like. Shoot, we ended the last one with Sir Frederick, didn't we? He's not here, but... Oh. This is Boo. And he is also... their fit.